Most people believe the limits of human mind are fixed, that intelligence is something you're born with, slowly shaped by experience, constrained by biology. Your thoughts live inside a skull, your memory fades, your attention drifts, and no matter how advanced technology becomes, there is always a gap between you and the machine. But what if the gap isn't permanent? What if the boundary between human and computer is not a law of nature but a temporary interface problem? That is the reality Neuralink is trying to break. Because the real bottleneck in the age of artificial intelligence is not computing power, it's bandwidth, the speed at which humans can communicate with machines and with each other. Right now, you interact with technology through layers of friction. You type, you tap, you speak. Each step is slow, imprecise, and limited. Your brain operates in complex electrical patterns, but you translate those patterns into crude signals like words and gestures. It's like trying to stream 4K video through a dial up connection. And as artificial intelligence accelerates, the gap becomes dangerous. Machines are getting exponentially faster, more capable, more integrated into every system we rely on. But humans are not upgrading at the same rate. We are becoming the slowest component in our own creations. This creates a silent imbalance, a world where intelligence scales but human control does not. So why hasn't this been solved? Because interfacing directly with human brain is one of the hardest problems in existence. The brain is not a simple machine. It is a dense, fragile network of billions of neurons, each firing in patterns that are still not fully understood. For decades, brain-computer interfaces existed only in research labs, bulky, invasive, and limited. The idea of safely embedding technology into the brain, reading its signals, and writing information back felt closer to science fiction than engineering. The risks were enormous, the technological challenges even greater, and the potential market unclear. So most companies stayed away, but not Elon Musk. Because Neuralink is not being built as a typical biotech company, it is being built as a 0 to 1 bet on the future of human cognition. At its core, Neuralink is driven by a single contrarian belief that the human mind is not the final form of intelligence. It is a platform that can be upgraded. And once you see the brain as hardware, everything changes. The goal is not just to treat disease, it is to build a direct interface between biological intelligence and digital systems, a bridge between mind and machine. But this is where most explanations stop and where Neuralink's story begins. Because the difference between an idea and revolution is execution. Neuralink's execution engine is not just the implant, it's the entire system built around it. Firstly, they developed ultra-thin threads, flexible electrodes that are far thinner than a human hair. These threads are designed to be inserted directly into specific regions of the brain, allowing precise interaction with neurons while minimizing damage to surrounding tissue. Then comes the surgical challenge. You cannot rely on human hands to perform this level of precision consistently. So Neuralink built a robotic surgeon, a machine capable of inserting these microscopic threads into the brain with extreme accuracy, avoiding blood vessels, reducing risk, and making the procedure scalable. This is critical because without scalability, there is no future. Then comes the implant itself, a small coin-sized device embedded in the skull connected to the threads. It records neural signals, processes them, and transmits data wirelessly. No external wires, no bulky equipment, just a seamless integration between brain and device. Finally, the software layer. This is where the system becomes powerful. The implant captures raw neural data, but the data needs to be decoded. Neuralink uses machine learning models to interpret patterns of brain activity and translate them into actionable outputs, movement, intention, communication. In early demonstrations, this allowed patients to control a computer cursor using only their thoughts, no hands, no physical input, just intention translated into action. But this is just the beginning, because once you can read signals, the next step is writing them. Simulating neurons to restore lost functions, to treat neurological disorders, and eventually to enhance cognition itself. This is where Neuralink stops being a medical device company and starts becoming something else entirely, an interface layer for human brain. What gives Neuralink its unfair advantage is not just technology, it is integration. Most research in this field is fragmented. Universities focus on theory, medical companies focus on compliance, hardware teams focus on components. Neuralink combines all of it into a single system: hardware, software, robotics, neuroscience, AI, all moving together, iterating at speed. And speed matters because the first company to solve this at scale doesn't just create a product, it defines the standard. The team behind Neuralink reflects this ambition. Engineers from aerospace, machine learning experts, neuroscientists, a high density group operating more like a deep tech lab than a traditional startup. Backed by capital, driven by mission, and willing to operate in one of the most complex regulatory environments in the world. This is not a side project, it is a long term infrastructure play. If Neuralink succeeds, the implications are massive. In the short term, it could restore mobility in paralyzed patients, give voice to those who cannot speak, treat conditions like Parkinson's, epilepsy, and depression. But in the long term, the end game is much larger. A world where the interface between human and computers disappears, where communication is no longer limited by language or typing speed, where thoughts can be transmitted directly, where knowledge can be accessed instantly, where the line between human intelligence and artificial intelligence begins to blur. At that point, Neuralink is no longer competing with other companies. It becomes infrastructure, the default interface for interacting with technology itself. The same way the smartphone became the gateway to internet, Neuralink could become the gateway to digital reality. And once that happens, the company doesn't just participate in the future, it defines it. But there is a tension here because this is not just a technological shift, it is a philosophical one. Who controls the interface controls the flow of information. If your thoughts can connect to machines, they can also be influenced, shaped, potentially even manipulated. The same system that can restore freedom could introduce new forms of dependency. So the question is not just whether Neuralink will succeed, it is whether humanity is ready for what comes after. Because for the first time in history, we're not just building tools to change the world, we are building tools to change ourselves. And once that boundary is crossed, there is no going back.